Hello, my dear students. Welcome to IK Sir Chemistry classes. Here we are in lecture number 10 on the chapter Symmetry and Group Theory. In this video, we will discuss the multiplication table of C3V point group. It is an important topic in this chapter and questions related to asked frequently in various competitive examinations as well as in general examinations. NH3 is the simplest molecule belonging to C3V point group. It has trigonal pyramidal shape and it can be represented as follows. In NH3 molecule, nitrogen atom is bonded to three hydrogen atoms Ha, Hb and Hc. These two solid bonds are towards the viewer while this dashed bond is away from the viewer. In actual practice, three hydrogen atoms Ha, Hb and Hc are present at the corners of an equilateral triangle and nitrogen atom is centrally above this triangle. NH3 molecule can be represented by an equilateral triangle ABC. This molecule is represented by an equilateral triangle ABC. The corners A, B and C of the equilateral triangle ABC represent the hydrogen atoms Ha, Hb and Hc respectively. Corner A represents hydrogen atom Ha, corner B represents hydrogen atom Hb and the corner C of the equilateral triangle ABC represents the hydrogen atom Hc. The nitrogen atom is present, not presented, is present centrally above this triangle and it has not been shown in the figure for the sake of clarity, for the sake of simplicity. Elements of symmetry present in NH3 molecule. E. Identity element of symmetry is present in all the molecules and it is also present in NH3 molecule. C3. Axis of symmetry. It passes through nitrogen atom and the center of the triangle. C3. Three-fold axis of symmetry. It is C3 which passes through nitrogen atom and the center of the equilateral triangle containing three hydrogen atoms. Sigma A. It passes through nitrogen atom and Ha atom. This NH3 molecule has been represented by an equilateral triangle ABC and sigma A. It is vertical plane of symmetry. It passes through nitrogen atom which is centrally above this triangle and has not been represented in this figure. Sigma A vertical plane of symmetry passes through nitrogen atom and Ha. It is sigma A. Sigma B, it is also vertical plane of symmetry and passes through nitrogen atom and Hb. It is sigma B. And sigma C, it passes through nitrogen atom and Hc. It is sigma C. All these three plane of symmetries pass through nitrogen atom which is present centrally above this triangle. It must be noted that the positions of these three vertical planes of symmetry are kept static as in this original figure it is sigma A, it is sigma B, and it is sigma C. Their positions are not changed during any symmetry operation. Symmetry operations that can be carried out on NH3 molecule. The following 6 symmetry operations can be carried out on NH3 molecule. Identity, C3, C32, that is C3 inverse, both are equivalent, and we will include C3 inverse symmetry operation. Sigma A, sigma B, and sigma C. It must be noted, as we have stated earlier, that the positions of planes of symmetry in NH3 molecule are kept static as in the original figure. These 6 symmetry operations of C3b point group can be multiplied in 36 different ways, as represented in the following multiplication table of C3b point group. The multiplication table of C3b point group is given on the next slide. It is the multiplication table for C3b point group. 6 symmetry operations E, C3, C32, that is C3 inverse, sigma A, sigma B, and sigma C have been kept in vertical positions. And these 6 symmetry operations have also been placed in the horizontal position. There are 36 places in this multiplications table whose entries represent the product. Let us consider the entries at position number 10. It is nothing but C3 multiplied by sigma A, and the product is sigma C. C3 multiplied by sigma A is equal to sigma C. It can be derived easily. Let us now consider the entries at position number 20. This position represents the product of symmetry operations sigma A and C3. Sigma A multiplied by C3 is represented at position 20, and the product is sigma B. Similarly, the entries at other positions represent the corresponding multiplications. Let us illustrate the product of some selected multiplications. Position number 11, C3 multiplied by sigma B. Here, the symmetry operation sigma B written on the right hand side is carried out first, followed by C3. Let us apply sigma B operation on this NH3 molecule. It is sigma B. The position of B will remain unchanged, while on reflecting through this plane, A and B will exchange their positions. The image of A will be obtained here. This is A, and image of C will be obtained here. It is C. Now let us apply C3 operation on this NH3 molecule. On applying C3 operation, B will move to this position. Here we will get B. A will move to this position. Here we get A, and C will move to this position. Here we get C. On applying sigma B and C3 operations, we get this orientation. and this orientation can be obtained by applying a single symmetry operation sigma A. If we reflect NH3 molecule through this plane, A will remain unchanged. The image of B will be obtained here as here, and the image of C will be obtained here. It is C. Therefore, the product of sigma B and C3 symmetry operations is equal to sigma A. Now, let us consider the product at position 26. It represents sigma B multiplied by C3. Here, the symmetry operation written on the right hand side is carried out first, followed by symmetry operation sigma B written on the left hand side. On applying C3 operation on this NH3 molecule, A will move to this position. It is A, B will move to this position. Here we get B, and C will move to this position. Here is C. And then on applying sigma B symmetry operation, it is sigma B. It must be noted that the positions of sigma A, sigma B and sigma C are kept static as in the original figure. On reflecting through this plane, the position of A will remain unchanged, while B and C will exchange their positions. This is the orientation of NH3 molecule obtained after applying C3 and sigma B operations successively. This orientation can also be obtained on applying sigma C operation to the original figure. It is sigma C. If this molecule is reflected through this plane of symmetry, C will remain unchanged and A and B will exchange their positions. It means the product of C3 and sigma B symmetry operations is equal to sigma C. Sigma B multiplied by C3 is equal to sigma C. Let us now consider the product at position number 23. Sigma A multiplied by sigma B. Here also, as usual, sigma B symmetry operation is applied first. On applying sigma B symmetry operation, this is sigma B. The position of B will remain unchanged while A and C will exchange their positions. Then be applying sigma A operation. It is sigma A as in the original figure. It is sigma A. On applying sigma A operation on this molecule, the position of C will remain unchanged. B will move to this position. This is B, and A will move to this position. It is A. This orientation can be obtained by applying C3 operation on the original figure. If C3 operation is carried out on this molecule, A will move to this position. This is A. B will move to this position. This is B, and C will move to this position. It means sigma A multiplied by sigma B is equal to C3. And let us now consider the product at position number 28. Sigma B multiplied by sigma A. Here also, as usual, sigma A operation is carried out first. On applying sigma A operation, that is reflecting the molecule through this plane, the position of A will remain unchanged and B and C will exchange their positions. Let us now applying sigma B operation. This is sigma B as in the original figure, and on reflecting through this plane, C will remain unchanged while A and B will exchange their positions. This orientation can be obtained by applying C3 inverse operation on the original molecule. C3 inverse operation means the rotation of NH3 molecule about C3 axis of symmetry by 120 degree in anti-clockwise direction. On doing so, A will move to this position. This is A. C will move to this position. It is C, and B will move to this position. It means the product of sigma B and sigma A is equal to C3 inverse. Here it must be noted that sigma A and sigma A multiplied by sigma B is equal to C3, while sigma B multiplied by sigma A is equal to C3 inverse. It means sigma A and sigma B symmetry operations don't commute with each other. Now the time for self-assessment. Prove that C3b point group is a mathematical group. Here is the answer. The symmetry operations of C3b point group, that is E, C3, C3 inverse, sigma A, sigma B, and sigma C obey all the four laws of a mathematical group as illustrated below. Law of identity. The identity operation, that is E, commutes with all other symmetry operations of C3b point group and leaves them unchanged. E into C3 is equal to C3, while C3 into E is also equal to C3. E multiplied by C3 inverse is equal to C3 inverse, and C3 inverse multiplied by E is also equal to C3 inverse. E into sigma A is equal to sigma A, and sigma A multiplied by E is also equal to sigma A. E multiplied by sigma B is equal to sigma B, and sigma B multiplied by E is also equal to sigma B. E multiplied by C is equal to sigma C, and sigma C multiplied by E is also equal to sigma C. It means the identity operation in C3b point group commutes with all other elements of this point group and leaves them unchanged. Law of closure. The product of any two symmetry operations and the square of each symmetry operation of C3b point group belongs to the same point group. There is a symmetry operation C3 and its square C32 is equal to C3 inverse, which belongs to C3b point group. Sigma A square is equal to E, sigma B square is equal to E, sigma C square is equal to E, and these belong to C3b point group. It means the square of each symmetry operation of C3b point group belongs to the same point group. At the same time, the product of any two symmetry operation of C3b point group also belongs to the same point group. Sigma A multiplied by sigma B is equal to C3. C3 multiplied by sigma A is equal to sigma C. Sigma A multiplied by C3 is equal to sigma B, and all these belong to C3b point group. It means the law of closure is obeyed in C3b point group. Law of inverse. Each reflection operation of C3b point group is the inverse of itself. It means if any reflection operation is multiplied by itself, we get identity operation. Sigma A multiplied by sigma A is equal to E, sigma B multiplied by sigma B is equal to E, and sigma C multiplied by sigma C is equal to E. It means each plane of symmetry is inverse of itself. and C3 inverse operation is the inverse of C3 operation, because if we multiplied C3 inverse by C3, we get identity operation. And these two symmetry operations, which are inverse of each other, commute with each other. C3 multiplied by C3 inverse is also equal to E. And the law of association. The law of association holds good among the symmetry operations of C3b point group. Let us multiply sigma A, sigma B and sigma B symmetry operations in two ways. In first way, sigma A is multiplied by sigma B first of all, and their product is C3. Then C3 is multiplied by sigma B and the net result is sigma A. Let us now first of all multiply sigma B and sigma B together. Their product is E, which is multiplied by sigma A thereafter, and the net result is also sigma A. If sigma A, sigma B and sigma B symmetry operations are multiplied in two ways by clubbing two symmetry operations in different ways, the net result is the same. It means the law of association holds good among the symmetry operations of C3b point group. Therefore, it is obvious that C3b point group is a mathematical group. Now the time for second self-assessment. Prove that C3b point group is not an abelian group. The mathematical group whose all the elements commute with each other is called an abelian group, and when this condition is not satisfied, the group is not an abelian group, that is non-abelian group. Here is the answer. All the symmetry operations of C3b point group don't commute with one another as illustrated below. Sigma A multiplied by sigma B is equal to C3, while sigma B multiplied by sigma A is equal to C3 inverse. It means sigma A multiplied by sigma B is not equal to sigma B multiplied by sigma A, and these two symmetry operations don't commute with each other. Let us see another example. Sigma A multiplied by C3 is equal to sigma B, while C3 multiplied by sigma A is equal to sigma C. It means sigma A multiplied by C3 is not equal to C3 multiplied by sigma A, and these two symmetry operations sigma A and C3 don't commute with each other. Therefore, C3b point group is not an abelian group. It is non-abelian group. Thank you for watching the video with patience and concentration. Please like and share it. If you have not subscribed my channel yet, please subscribe it so that you may get informations regarding my new videos in future in time. Thank you again.